Hello everyone, my name is Wedashwara. Today with my fellow researchers, Mr. Andi and Mr. Ariyan from Department of Informatics Engineering, Mataram University, and Mr. Agus that currently is taking a study in the Technology Management and Economic and Policy Department of Seoul National University, would like to presenting our research with title Smart Solar Power Hydroponic System using Internet of Things and Fuzzy Associational Mining. So this is our presentation context. First is a background. So background of this research is hydroponic, which agriculture with limited space and relative fastest grow method. And we're supposed to make a research for the nutrition firm technique and the flow technique that need electric water pump for nutrition distribution. So we would like to make a portable hydroponic system that not depending with alternative current power source that have a problem with environment like a thunder or pollution or something. Okay, so our solution is hydroponic with solar energy, but there's also some problems. So we don't know how much setting that we need to sufficient the continuous operation, especially in the night. So we don't know our environment is effective for the energy production cycle, and we would like to know the environment effect to the efficiency of the solar cell. Okay, so our proposed solution is a smart solar power hydroponic system. Basically, water pump that powered by solar energy and batteries, but we add Internet of Things and machine learning algorithm in there. So the Internet of Things basically collect the environment data, including light intensity, air temperature, and humidity, that could be used to both plantation and energy generation, and DC voltage that generates by solar cell and use from the battery. And we do the regression using machine learning to classify the condition with the rule base and do the regression about the energy availability in many situations. Okay, so second part is review of the proposed framework. Okay, this is a general view of the system. So basically, there is a three part of IoT system that the device that used to collect data. First is for environment that collect light intensity and air temperature and humidity, and another two is IoT for to collect the voltage and current data from the solar cell, and other one is from the battery. So one is for input, other one is for the output. So all collect data will store in the machine learning server that will do the prediction of energy availability using a fuzzy association rule mining. Okay, the output of the system is data. So data is environment data and the energy data in many conditions that we can put them as fuzzy rule with combination of precedent and dependent within time series data. Okay, the other output is predictions, energy availability in the hour for the short period low energy generation, rainy long period low energy generation, and sun position half day low energy generation, and the night with without energy generation and full energy from batteries. Okay, so this is the flow chart of the system. So basically, we do the two part of data collection, which in the daytime to extract the precedent part of the rule, and in the night time to do the rule extraction for the dependent. So we, both part will use as of prediction, and we do the regression evaluations, and we repeat data collection until the accuracy is satisfied. Okay, so this is a basic concept of fuzzy adjacent rule mining that we use for the time series data. So there's a two variable show in there. Basically, there is more than this. Okay, so there is a time series for the x-axis. So we can see each temperature label 1 to 3, and like also 1 to 3. So there is a morning time which partially bright, partially cloud, and in the afternoon we can see hot and bright in there. So best condition maybe. So in the noon, we can see there is a bad sun position caused by a tree or something. So there is a not high light intensity in the night. So the black part from the 90 o'clock is night time. So we will use a full battery power in there. Okay, so this is a hardware connection. There is so green arrow show the combination of data and power. Red arrow show the pure power, and yellow arrow show the pure data connection. So basically, mix arrow only happen in the energy condition which produced by solar and battery, because voltage and current is power and also data. Okay, something like that. So so we can see each IoT system also use mini solar cells. So the IoT device itself don't disturb the power usage for the hydroponic system. So we can get the pure power consumption data for the hydroponic system. Okay. So part 3 is detail of the developed system. So this is the per board layout for the IoT system for environment and energy, which both use a voltage regulator so to make the energy is constant, so don't break the microcontroller. Okay, so this is a detail of farm. So environment data is used as precedent, and the power data input and output will use as a dependent. So the condition of the power consumption happen because the environment, okay, something like that. So we can see there is in the night time we can calculate how long the voltage of the input still remaining to supply the power for the hydroponic system. Okay, so this is the regression part. So basically we will do the prediction about partial direct power, morning charging time, full direct power, full battery. When the battery is full, so the solar cell capable to give a direct power to the system. So the batteries keep remain full. So partial direct power happen in the bad sun position or cloudy or rainy or something, and full battery power in the night. So the uh, capability of battery to supply the power to the in the night is depend on how much efficiency of energy generator in the daytime. Okay, so we will conclude the data automatically using the algorithm to the rule-based system. Okay, so this is the most important part: simulation and result. Okay, this is a simulation condition. So unfortunately, we only capable to do data collection in the 3 days with the 1 second refresh rate. So it's still big data. So but just a 3 days. So lack of variety. Location is Mataram, Lombok, in my backyard of house. Not full address or privacy. So basically 3 solar cell and 3 battery. And we also use a solar charge control to avoid the overcharging. And we use a hydroponic system, 24 pots with divide into 8 part. Okay, sorry, 4 pot with 1 meter stand. So not install hike, so we don't need a hike power of water pump, just 20 watt. Okay, so this is a system installation. This is the hydroponic system, and we put the solar cell not on the rooftop for the purpose. It could be disturbed by the sun position. Okay, so it can simulate the condition of a portable hydroponic system. So we can install it on the middle of forest or something. Okay, which have the good environment condition for the plantation without using a specific treatment something. So this is a solar charge control, and we use a WAGO to make a parallel of 3 solar cell and 3 batteries. Okay. So this is IoT hardware. Left is environment. Right is power. Okay. So this is collected data. So we start to talk about the data. Okay. So 4 part. First is fuzzy index, which show 1 is best condition and 3 is not good condition. Okay. For example, for light intensity, in fuzzy index 4 is in the night time, so the lux is just 1. So best part is 1, which capable to high amount of lux, which that we need for the good energization, and also temperature and humidity. It should be not too high. Okay, and the right part is percentage of each fuzzy membership happen in the day. Okay, so it could be show the day 1 is cooler and brighter than day 2 and day 3, and also less humidity. Okay. Okay. So this is the collected power data. So it's basically 4 variable with voltage and current, both for the solar panel and battery. Okay. So we can see for the solar voltage, this is the maximum capacity is 70 volt. So but in the environment condition, maximum of voltage generated is 60.01. Okay, and the solar current is show the direct power or used to charging. We can separate them, okay, because there's maintained by the solar charge control. Next time maybe we should make our own solar charging control to separate them, which one used to direct power and which one used to uh, charging, okay. So battery voltage 12 volt is means the battery is full, okay. And so battery current when they are low, so but that show a battery is not in use, okay. So this show the mistake happen in the research. Why they in the Taiwan there is a higher sorry, lower usage of battery compared to day 2 and day 3, because we really sorry that we start the data collection in the morning, okay, for the day 1. So we start in the morning with battery is full charging. So there is no data in the first day 1 of partial power to use in charging and direct power, okay. So that's not good actually. That make some noise, okay. So it's more clearly showed by the day hour, okay. We, as we can see, direct power in the day 1 is very high, 11.12, okay, because we start in the full battery condition. The valid condition is battery is not full because have been used in the night, okay. That's the problem, okay. So actually that day we just taking a data on 3 day, but 1 day is having some mistake, but don't worry, that mistake can cover with a rule-based regression, okay. So basically this is a rule dependent happen because of precedent and support and confidence of that rule. So extra bracket in the next is show the or condition. So T1 or T2 have the same dependent condition. So also this in rule 8 show the condition which there is a not good so basically direct power is only capable if the generated power is enough to fully power the system although battery full. So I forgot to mention that although battery is full, but if the light intensity is low, we can not supply the full direct power from the solar cell. But in the rule 8, it shows although the power generation is low, but we can still maintain the relative high battery voltage. This happened because we start with full charging. Okay, that's the problem. Okay, so but this is a regression result. So basically, we made the regression. Yeah, regression based on the best rule that matching for the condition. We do the defuzzification from the extracted rule, and with the rule-based regression, we can ignore the data that not rule that not match with the condition. Okay, so for I forgot to mention that we use day 3 as testing data, day 1 and day 2 as training data. Okay, so the regression is successful because actually this is not difficult data, because we use a water pump that have a constant power usage, 24 hours. So we can get the mean absolute error just 0.06 and mean square error 0.25. Okay, the conclusion and future work. Okay, so the solar power hydroponic system capable to do the energy supply for 24 hours with this setting, and the IoT system capable to collect data and do the regression with low error rates, and also capable to extract environment data that with high average of support and confidence. So it's successful as a regression and it's successful as rule extraction. Okay, exactly. So future work, we got a lot of work to do in the future. So basically in this research, we just mostly talk about the power of the power system of the hydroponic system, not much about plantation, but in the future we promise talk more about plantation. So we would like to collect the longer data, and so we can measure the effect of the system to the plantation. And we would like to build the smart hydroponic system, hydroponic monitoring system, which also measure the plantation data such as total dissolved solid or pH, water temperature, water level, water flow sensor as dependent, and the power as a precedent. Okay. And the smart hydroponic nutrition system with mini water pump and water flow sensor, so we can supply the accurate portion of nutrition depend on the condition. For example, if pH is too high, we can supply automatically the pH down nutrition or something. Okay, so that we would like to do in future. So this hydroponic system is not finished yet, but it's just a start. Okay, so that's all. Terima kasih. Thank you. Arigatou gozaimashita. Gamsahamnida.